section 2.2 talks about graphs of functions. So this is general for all graphs. There are 6 graphs that we should familiarize ourselves with it. In section 2.2 there's a page in there that has those graphs, and we're going to elaborate on these graphs. So we're going to sketch these graphs 2 ways. One way we're going to plot points. I'm going to show you how to do that. That's in section 2.2. And then in section 2.6 we're going to just translate and shift and reflect graphs, compress, do all of these awesome things. So we're going to learn how to plot points and how to just sketch a graph. If a problem says sketch a graph by making a table of points or by plotting points, then you have to show the points. The majority of this course, it says sketch a graph. You don't have to plot any points. Now, some of the graphs that you should familiarize yourself with is y equal x squared is a parabola. The main 3 points that form the main characteristics of the parabola are those 3 dots. If you connect them in a smooth curve, you get the parabola. This is the vertex, extremely important. A cube looks like a parabola on the right hand side and the opposite of that on the left hand side. Again, the main 3 points, that's what we're going to go after. When you see an absolute square root of x, the main 3 points that set or give the properties of a square root, we're going to go after, and you connect those with a smooth curve. Cube root looks like a square root and the opposite of that. Absolute value looks like a v, but again, the main 3 points that pretty much preserve the characteristics of this graph we will find. And 1 over x is a graph that looks like this. No need to focus much on that, because when we get to chapter 3 we're going to tackle that all by itself when we do rational functions. For now you're going to see it every now and then, but in chapter 3 we're going to tackle that head on. So to sketch a graph, sketch the graph of a function by making a table. Alright, well this is how we're going to make it. You could choose any points you want. This is what we're going to do. We're going to go after those 3 points that I showed on every graph. To do that, you would take, where would the inside of the square, the inside of the power function, the cube, the inside of kind of like that x to the 1/2, the cube root, the inside an absolute value. Where does that equal 0? A point above it, a point below it will give you those 3 points that you want. Connect them with a smooth curve, assuming you're comfortable with these graphs, then you'll be able to get them. This is a parabola. Where does that equal 0? That's the key point, at 0. A point above it and a point below it will give me those 3 points. If I throw 0 in there, 0 minus 2 is negative 2. That point corresponds to this point, the vertex. If I throw a 1 in there, 1 squared is 1 minus 2 is 1. You know what? I could scale this. So it was 0, negative 2, 1, 1. And if I throw a negative 1 in there, negative 1 squared is positive 1 minus 2. Oh, that's a negative 1. I'm sorry. So 1, negative 1, and negative 1, negative 1. And again, these 3 points correspond to these 3 points. All what you have to do is connect them with a smooth curve. There's your problem. A problem like this, for now, that's x minus 2 squared. If you want to pick points, and again, if the problem asks to pick points, you should pick, where does that equal 0? That equals 0 at 2. A point above 2 and a point below 2 is going to give you the characteristics of the graph. Throw a 2 in there. 2 minus 2 is 0 squared. That's a 0. 2, 0. 3. If you throw a 3 in there, 3 minus 2 is 1 squared. That's a 1. And if you throw a 1 in there, 1 minus 2 is negative 1 squared, that's a 1. Again, the 3 points. Connect those with a smooth curve. And that's pretty much all there is to it. When I get to this problem, again, where does that equal 0? That's the main, that's the easy, it's not the only way, but that's the easiest way out. A point above it and a point below it will do the trick. Throw a 0 in there. 4 minus 0 is 4. Throw a 1 in there. 4 minus 1 is 3. Throw a negative 1 in there. Negative 1 squared is 1. 4 minus 1 is 3. 0, 4. That's 1 point. 1, 1, 2, 3. And negative 1, 1, 2, 3. And again, remember, the main point, that's the vertex, that's the key point for a parabola, and this graph is upside down. If you pick points, you don't have to worry about that. And how about the next problem? Where does the inside equal 0? At negative 1. A point above negative 1, keep in mind there's negative 1, a point above it is 0, and a point below it is negative 2. A negative 1 in there will give you a 0, a 0 in there, 1 squared is 1. If I substitute in a negative 2, negative 2 plus 1 is negative 1 squared, that's a 1. So 1, 0, 0, 1, and 1, 0, 0, 1. Okay, something's not right. Oh, I'm sorry. That was negative 1, 0. I was saying it's not matching. Negative 1, 0. 0, 1, and negative 2, 1. Again, the main characteristic of a parabola. Connect those with a smooth curve. There, oops, that doesn't look pretty. Connect those with a smooth curve. And there's the parabola. So, you'll notice this doesn't take that long. Now, by picking where that equals 0 and a point above it and a point below it, what you're doing, you're guaranteeing that the points will stay small and easy to graph. Where does the inside equal 0? At negative 3. A point above negative 3 is negative 2. A point below it is negative 4. That does the trick. A negative 3 in there will make that a 0. Minus 2 is negative 2. A negative 2 in there. Negative 2 plus 3 is 1. Squared, that's 1. Minus 2 is negative 1. And a negative 4 in there. Negative 4 plus 3 is negative 1 squared, that's 1. Minus 2 is negative 1. Negative 1, negative 2, negative 3, negative 1, negative 2. Negative 2, negative 1. And a negative 4, negative 1. Again, the three main points that form the characteristics of any parabola. And if I was to look at something really complex, where does that equal 0? At negative 3, just like the problem before, a point above it and a point below it. A negative 3 in there will make that a 0, minus 1, that's negative 1. A negative 2 plus 1 is 1, squared, that's 1. Negative 2 times 1 is negative 2, minus 1 is negative 3. And a negative 4 plus 3 is negative 1, squared, that's a positive 1. So negative 2 times 1, negative 2 minus 1 is negative 3. Negative 3, negative 1. Negative 1, negative 2, negative 3, negative 1. Negative 2, negative 1, negative 2, negative 1, negative 2, negative 3. And negative 1, negative 2, negative 3, negative 4, negative 1, negative 2, negative 3. Connect those with a smooth curve. There's my parabola. No need to worry. What about the cube? Well, the cube looks like a square and its opposite. That's kind of how I memorized it back in my days. Where does that equal 0? That equals 0 at negative 1. A point above negative 1 is 0, and a point below it is negative 2. Again, 3 point will get you any graph that you want with its main characteristics preserved. Put a negative 1 in there, that's a 0. So negative 1, 0, that's 1 point. Put a 0 in there. 0 plus 1 is 1 cubed, that's a 1. Remember, and a negative 2 plus 1 is negative 1 cubed, that's a negative 1. Negative 1, negative 2, negative 1. So remember, on the right hand side it looks like a parabola, and on the left hand side like the upside down parabola. There it is. preserving everything about a parabola you can think of. I'm sorry, that was meant to be a cube. There we go. So if I was to go ahead and figure out where does the inside equal 0, that's the key point. That's at 4. A point above 4 and a point below 4. Throw a 4 in there, that's a 0 minus 2, that's negative 2. Put a 5 in there. 5 minus 4 is 1. Cube, that's 1. Minus 1 minus 2 is negative 3. So 4, 1, 2, 3, 4, negative 1, negative 2. 5, negative 1, negative 2, negative 3. And 3 in there. 3 minus 4 is negative 1. Cube, that's a negative 1. Negative 1 times a negative 1 is positive 1. Minus 2 is negative 1. 1, 2, 3, negative 1. Again. So I noticed that there's a negative there. I knew this was going to flip. So it looks like a parabola on the left and the opposite of that on the right. Maintaining everything there is about the graph. And if I proceed and go to a cube root, I know what a cube root looks like. I notice there's a negative. So instead of the graph looking something like this, I'm expecting it to go the other way around. But the points will give it away. That's something you're going to have to worry about more when we do section 2.6. X and Y. There is no restriction on domain unless you are dealing with specifically a square root. So, where does the inside equal 0? A 1. A point above 1 is 2 and a point below it is 0. Throw a 1 in there, that's 0. 1, 0. Got it. 2 in there. 2 minus 1 is 1. Cube root of 1 is 1 times a negative, that's a negative 1. 1, 2, negative 1. As expected. So I know it's going to look like an upside down radical. And if I put a 0 in there, 0 minus 1 is negative 1. Cube root of negative 1 is negative 1 times a negative is a positive. And the left side looks like this. So the negative reflects the graph. How about this graph? Well, absolute value, okay, no big deal. Where does the inside of an assuming you know what an absolute value look like the V shape. Where does that equal 0? At negative 3, a point above it and a point below it. A negative 3 in there will make it 0 times 2, that's a 0. A negative 2 in there will make it a 1. Absolute value of 1 is 1 times 2, that's a 2. And a negative 4 plus 3 is negative 1. Absolute value of that is negative 1 times 2, that's a 2. Negative 3, 0. Negative 2, 2. And negative 4, 2. Connect those with straight lines. Why straight lines? Because this is an absolute value. And that's how it works. Not a smooth curve, a straight line. Now if you pick more points, you'll figure out that it does fit on a straight line. This is the only type of graph up till now that I gotta be careful with. Why is that? Because of domain. I figure out where that equals 0. And I know the domain, that right there is bigger than or equal to 0. So I can only pick points bigger than 0. I can pick 1 above. I can't pick below. But since it's a square root, I should pick perfect. I could pick 2, but that's square root of 2 is not a whole number. So 3 doesn't work. I'll go for 4 since I could pick. Put a 0 in there, that's a 0. Put a 1 in there, the square root of 1 is a 1. Put a 4 in there, the square root of 4 is a 2. So this is by choice. 0, 0, 1, 1, 2, 3, 4, 1, 2. Connect those three with a smooth curve. There it is. What if they shifted that? Not a problem. This method allows you to take all shifts into account. So where does the inside of that equal 0? At 2. Remember that you want the domain in this case. Domain x minus 2 must be bigger than or equal to 0. So you can only choose values that are bigger than or equal to 2. Well, I chose 2. 3 is good because I know already 3 minus 2 is 1. And square root of 1 is a perfect square. 4 is unwise because 4 minus 2 is 2. 5 is unwise. I'll go for 6 because if I put a 6 in there, 6 minus 2 is 4, square root of 4 is 2. 3 in there, 3 minus 2 is, I almost forgot about that 1. So you get a 2 plus 1, which is 3. A 3 in there. 3 minus 2 is 1 square root of 1. 1 plus 1, that's 2. And a 2 in there will give you a 0 plus 1, which is a 1. So in this case, let me just shift that a bit down. And 2, 0. 2, 1, I'm sorry. That's where you start. 1, 2, 3, 1, 2. And 1, 2, 3, 4, 5, 6. 1, 2, 3. There's my graph. That's how these problems work. I'm going to stop here for this and continue on in the next video.